Hello everyone, welcome once again to another interesting edition of your physics preparation on your platform, your study path. Remember, the focus hasn't changed. For those of us that have terminal examinations to write this year, talking about your O-level examinations, your physics O-level examinations, talking about your Waec, NECO or GCE examinations, and not forgetting your Jamb UTME examination. That's why we are here. Please endeavor to mute your mic so that you don't in any way distract other people. Once it's time for the question and answer section, I would entertain as many questions as possible. So I'm sure with what we looked at the last class, we had a clear grasp of what refraction entails in its entirety. Today we'll be looking at another interesting topic in physics with which we could be asked questions, be it in the theory sections for those writing Waec, NECO or GCE, or be it in the objective section for those writing Jamb-based examination. Let's get right into it. So what are we looking at this morning? We're looking at today equilibrium in liquids. Equilibrium in liquids. Remember, we made reference to the fact that in solids, you also have equilibrium, whereby you will talk about the three types of equilibrium in solids. The first being stable equilibrium, the second being unstable equilibrium, and the third being neutral equilibrium. Those are equilibrium states in solids. But whenever you are making reference to equilibrium in liquids, we want to look at certain terms, which include Archimedes' principle. I'm sure you are familiar with this. We have principle of flotation. Then we'll make reference to density as well as relative density. So our focus and concern will be around these topics. We want to look at Archimedes' principle, understanding the concept of Archimedes' principle and how it relates to calculation questions. Also, we want to understand the concept of what? Principle of flotation. Not forgetting picking density from our SS1, where we did density, relating it with what? Relative density. So all these and more are what we'll be looking at today. So let's get right into the business of today. The first thing will be Archimedes' principle. What does Archimedes' principle state? To get a clear understanding of Archimedes' principle, take your mind back to the instance of a man fetching water or a woman fetching water from the well. This is peculiar for those that are familiar with what? Well. Ask around. Maybe you've seen somebody who fetches well before. They will tell you that whenever you throw your fetcher into the well and you are trying to pull the fetcher up, while the fetcher is still inside the water, it appears very, very easy to pull. But the moment the fetcher comes out of the water, it becomes very heavy. This can only be explained under the principle known as Archimedes' principle. And what does it say? It states that when a body is partially or fully immersed in a liquid, in a fluid, it experiences an upthrust which is equal to the weight of the fluid displayed. Let's have it on the board. So you can write Archimedes' principle. It states that it experiences an upthrust. So this is the definition. This is what we will state what Archimedes' principle as. It states that when a body is partially or completely immersed in a fluid, it's going to experience an upthrust. Then we ask ourselves, what does it mean? What does upthrust mean? It is gotten from the word Thrust. Remember, thrust is in physics is referring to what? A push or pull, which means thrust is a force. Thrust is a form of what? Force. When we are now being told the direction of the force, we are having what? An up force. We are being told that what? Whenever you are dipping a body inside a fluid, whether partially or completely, you are dipping everything inside or you are dipping part of it, it is going to experience an upward push inside the water, which is equal to the what? Weight of that fluid that is displaced. Here we have it. You have a container. You are dropping what? A ball, for example, inside it. You are dropping what? A ball. Remember this experiment in your secondary school. Whenever you are dropping a ball inside a viscous liquid, for example, you have that the weight of the ball will be moving downwards. The weight of the ball is causing the ball to move downwards. But what happens? The water is going to provide what? A balance, a form of what? Opposite push, pulling the what? Pulling the body upwards. That force which pulls a body upward, it pushes a body upward inside the liquid, is known as upthrust. Is known as upthrust. Although in this case, you are going to have another force that would pull it upward, which is the viscous force. We are not looking at viscosity as a form of friction in liquid yet. So what we are capitalizing on only is about this upthrust force. The up force that tends to push a body upwards when it is actually what? Immersed in the liquid. Now, here is it. Definition, upthrust is the word. Put that in mind. We can now say that according to Archimedes' principle, upthrust can actually be calculated. And how do we calculate upthrust? We say the weight of a body in air minus the weight in a fluid. And why are we saying fluid? Liquid or gas? Liquid or gas. Upthrust can be calculated by saying the weight in air minus the weight in a fluid. The difference between the weight of the body in air minus the weight inside what? A particular fluid, liquid or gas. Not only this upthrust can still be calculated. Remember, it is a type of what? Force. And what is the unit of force? Newton. So we know that what? This guy is measured in Newton. Unit is Newton. It is measured in Newton because it is what? A type of force. Aside this, we can also calculate upthrust using the formula that says that upthrust is equal to rho Vg, that is density multiplied by volume displaced multiplied by what? Acceleration due to gravity. So what are we making reference to? Density, rho, volume, and G. That marks our formula for upthrust. Aside having weight in air minus weight in a fluid, you can also calculate upthrust by saying that what? The density of that body multiplied by the volume that is displaced inside the fluid multiplied by the acceleration due to gravity. And remember, acceleration due to gravity is a constant. by the value 9.8 meters per second square, or in full value, approximated value, 10 meters per second square. That being said, we are getting somewhere. We've understood what Archimedes' principle states. Next is the what? Principle of flotation. Principle of flotation. What does principle of flotation state? It states that a body will float when it displaces its own weight in the fluid in which it is what? Immersed. It is going to float when it displaces its own weight in the fluid in which it is what? Immersed. What do we mean by this? Try to take a mental picture of a bucket filled with water, and you are having a baler, a form of what? Small container. And what you do is you dip your hand inside the container and you are pressing. Let's assume that we have our big bowl filled with water, and we now have our container on top. We have our container on top of the fluid. You are now pressing your hand inside the container. You are pressing it with a force inside the container such that it is pushing against the surface of this water. You are going to experience some amount of force that is kind of resisting your hand. And why is that? It's because there is an upthrust force that is tending to balance the weight of this what? Of this container inside the liquid. It is on the principle of flotation that what? Ships move on water. The reason why you are having that what? Ships will never sink is simply because it is displacing its own weight inside the what? Water where it is resting on. And check it out. For a ship, for example, let's assume we have our water body. We have our water body. And we have our beautiful ship. Like this with the mast. Don't mind me. We have our ship this way. And as it is, you are going to have that some part of the ship is resting below the surface of the water, while some part is what? Above the surface. It is simply because you are having the what? The weight of the ship displacing some portion of water in it. It is displacing its own mass in the liquid in which it is immersed. Remember that what? The water itself will create what? An opposing force. It tends to balance out the weight of the what? The weight of the ship. The weight of the ship is acting downwards. The upthrust force of water is pushing against it underneath. And because it is evenly distributed, the ship is not going to sink. But compare it with your stone. You drop a stone inside water, the mass being enclosed. What happens? It is going to sink. And the reason is this. You don't have what? A balance between what? Between the upward force. The mass is enclosed and you don't have a situation whereby the weight is being balanced by what? The upthrust force of the liquid. There's no balance. There's no what? Balance between the weight of the what? The weight of the stone and the upthrust force, which is meant to push it upward. Let's continue. Now, all this being said in a bit to what? Make the explanation clear. Now, listen to this. When you have the principle of flotation, you have Archimedes' principle. You must understand that what? They would use it to ask you a question as to why a body is floating or what volume of what? Body would be floating in a liquid. Or what would be the what? Upthrust force that will be experienced by a body when immersed or when a particular portion of its volume is immersed in the liquid. That is the goal. The calculation part is the goal. In terms of what? Non-calculation part, they could ask you, oh, what do we have with respect to what? Archimedes' principle. Can you state it? With respect to what? The principle of flotation, can you state the principle of flotation? It is now what? A question whereby you understand the basics behind the principle of flotation. Check this out. We said upthrust can be calculated by using some parameters. The weight in air minus the weight in fluid. Very easy. What if we are not given that? We can calculate it by saying density multiplied by volume displaced multiplied by acceleration due to gravity. Then the question will now be, how do we determine volume? That marks the next aspect we are considering. Density. Density. How do we calculate density? It is first for us to understand what exactly is the definition of what? Density. We said that what? Density is the ratio of the mass of a body to its volume. The ratio of the mass of a body to its volume. What are the units for measuring what? Density. We say it is measured in kilogram per what? Meter cube. Or you are picking gram per cm cube. This form the two words, the two basic units for calculating what? Density. Mathematically now. Mathematically, we can say that density denoted by rho. Density denoted by what? Rho. This symbol is equal to mass over volume. The unit of mass being what? Kilogram. And the unit of what? Density being, volume being what? Meter cube. So, kilogram per meter cube. Because you would have to determine the density in relation to the volume that is displaced before you can multiply it with what? The acceleration due to gravity. We are going to see all this. Note, and note. Students easily fail this part of the question, be it in Jamb, be it in what? The O-level examinations. And why do they fail it? It's simply because they don't understand that as far as the density we are talking about is concerned, we are making reference to what? The density of the body. It is the density of the body we are using. A stone is immersed in water. It is the density of the stone we are using, not the density of the water. Now, the stone is completely immersed. That means the volume that is displaced is the whole what? We are considering what? The total volume of what? Of the solid, of the stone being displaced in the water is what we are considering. Meaning that what? The volume of the stone present inside the water is what we are going to consider in this case here now. Note, here density of the body, here volume displaced inside the liquid, inside the what? Fluid, is what we are considering. Density displaced in fluid. Two key things. When we start solving questions, you'll get to understand better. Now, we have that what? Density has a relationship. When you are comparing what? Density of various substances, we have a way for which we can compare them together. And that's how we came about another term in physics, which we know as relative density. And that is making reference to what? The density of a substance in relation to the density of what? Equal volume of water. When you are making a comparison between any substance and water as a reference point. And why is this? It's simply because the density of water is a constant value that you can easily what? Have in your head. What is the density of water? It is simply 1,000 kilogram per meter cube. When you are converting to its gram value, you are going to have 1 gram per cm cube. Density of H2O. Chemistry students. Density of water. 1000 kilogram per meter cube or 1 gram per cm cube. That forms the basis of what? The density of water. So we are comparing it with respect to what? The density of water. The density of any substance in relation to density of water. We target relative density. So what are we going to write? Relative density now. So that we look at the storyline part before we get down to the calculation aspect. Here we go. We say that relative density it is the ratio of the density of a substance to the density of water. To the density of what? Water. To the density of water. If you are not picking this, then you can make reference to what? You can make reference to another definition. And you will say that what? Relative density is the ratio of the weight of a substance in air to equal to weight in equal volume of water. So we have formulas to this effect. We have formulas to this effect that governs what? Relative density. Look at it. We started with Archimedes' principle. We made emphasis on Archimedes' principle, stating that when you have a body, partially, part of it is immersed in a liquid, or you have the whole body completely immersed in a liquid, it is going to experience an upward force that is going to push the body up, and that force is equal to the weight of the what? Fluid that is displaced.